In the previous video, I discussed the image formation by flat mirrors. Now let's discuss the image formation by curved mirrors. There are two types of curved mirrors in existence. We have concave mirrors, where the reflective surface is on the back side of the mirror, and the incident light rays are incident upon the mirror like so. And then we have convex mirrors, for which the reflective surface is again behind the mirror, but now the curvature of the mirror is reversed, and the incident light will hit the mirror like so. First, let's look at the geometry of a curved mirror, which we will use in order to explain how to build images of objects placed in front of the mirror. So again, here is the mirror. Point M here is the middle of the mirror. Point F is the focal point of the mirror. That is the point at which all the light rays reflected from the mirror are going to focus. Point C is the center of the mirror. This is the center of the curvature of the mirror itself. So this mirror, being curved, is a part of a spherical surface which has a center at point C. Then the distance from point C to the middle of the mirror is the radius of this curvature. Let's call it R. The distance from the focal point F to the middle of the mirror, this distance, is called the focal distance. And we label that with F. There is an important relationship between the radius of curvature of the mirror R and the focal distance F. And this relationship is given as the focal distance F is equal to the radius of the curvature divided by 2. Here you can see a nice schematic drawing of a concave mirror. The image on the left is an actual concave mirror on which 4 laser beams are incident upon, and we can see the reflected beams converge at one point, and that would be the focal point of the mirror. So the ray diagram of the light rays incident upon the mirror itself show that all the reflected light rays converge at the focal point. One more thing that I must add is that this dotted line right here that splits the mirror in two, intersects the mirror in two equal parts, is called the optic axis. So let's discuss now how the formation of an image from an object placed in front of the mirror is determined. So for this purpose, I'm going to look at this diagram here on top. So on the left-hand side here, above the optic axis, I have my object. And I'm going to look at 3 specific light rays that come from the object and reflect from the mirror, and use those 3 specific light rays to determine the position of the image. So the 3 light rays are: number 1, along the radius of the curvature of the mirror. So this light ray starts from the tip of the object, hits the mirror. Since this is along the radius and the mirror is a part of a spherical surface, That means that this light ray is incident perpendicular to the surface of the mirror here. That means that it is going to reflect straight back and go back on the way it came from. And so this light ray passes through the center of the mirror. Light ray number 2 is parallel to the optic axis, and after reflection is going to pass through the focal point. So light ray number 2 is incident upon the mirror parallel to the optic axis, and after reflection passes through the focal point F. Light ray number 3 passes through the focal point, hits the mirror, and it reflects parallel to the optic axis. So light ray number 3 passes through the focal point, reflects from the mirror parallel to the optic axis. So then if I combine all these 3 light rays, I get this situation right here. And I noticed that all of the light rays after reflection intersected this point. And so this point will be the location of the image of the tip of the object. And so then I can use those same 3 light rays coming from every point of the object, and that is going to construct the image of this object. So a few terms that we use in regards to the image of the object here in this case. The image is inverted because it points below the optic axis. Notice how the object points up from the optic axis, but the image points down from the optic axis. So the image is inverted. Also, the image is in front of the mirror. Then we say that the image is real because it is in front of the mirror. Now, if we look at the diagram here on the right-hand side, the image is placed between the focal point and the mirror. And so by using the 3 light rays that I already discussed, I see that after reflection they diverge from each other. So they are never going to intersect anywhere in front of the mirror. But if I continue them behind the mirror, they intersect at a point which will be the tip of the object in this case. So I can then use the same 3 light rays for all points of the object to build the image, and the image is behind the mirror. So because the image is behind the mirror, right here, we say that the image is virtual. So that is not a real image. And also, since the image points above the optic axis, we say that the image is erect. So the image points above the optic axis. Let's look now at a convex mirror. So for convex mirror, if we have a parallel beam of light rays incident upon the mirror, after reflection those light rays will diverge from the optic axis. And here on the left hand side we have an actual image of lasers that are hitting a convex mirror, and as you can see, after reflection they are diverging from each other. However, if we continue the light rays after reflection on the opposite side of the mirror, we find that they are going to converge at the focal point of the mirror. So for a convex mirror, the reflective surface is on the back right here. This is the glass part of the mirror, and the focal point is behind the mirror. The center of curvature of the mirror is also behind the mirror. And so in the diagram below, we have an example of how to build the image of an object placed in front of the mirror. The 3 rays that I discussed on the previous slide are used here again. Ray number 1 hits the mirror so that it reflects straight back. If I continue this ray behind the mirror, it is going to pass through the center of the mirror. Ray number 2 is incident upon the mirror parallel to the optic axis, and then after reflection, it diverges from the optic axis, but if I continue it behind the mirror, it passes through the focal point. Or it appears as if it's coming from the focal point. Ray number 3 is incident upon the mirror, as if it is going towards the focal point of the mirror. And then upon reflection is parallel to the optic axis. So if I continue that ray behind the mirror, it will be parallel to the optic axis. So the three virtual rays behind the mirror intersect at this point, and that is the tip of the image of this object. And so I can then build the entire image. And from the previous slide, we know that when the image is behind the mirror, that is a virtual image. The image in this case points up from the optic axis, so therefore the image is erect. And so following those simple rules with the terminology that I discussed, one can build the image of any object placed at any distance in front of any curved mirror.